So, hey, I'm Ben Thomas. I'm the Director of Hydrogen Production for Mitsubishi Power. We're a subsidiary of Mitsubishi Heavy Industries. And my role, my team is responsible for delivering hydrogen production equipment for any of our projects in the Americas. And so right now, that looks like we're executing on the Advanced Clean Energy Storage project in Delta, Utah. I'll talk about that a little bit. The purpose of my presentation today is about validation and collaboration. So one takeaway I want for everyone today is how Mitsubishi Heavy Industries and Mitsubishi Power approach validation and how we use that validation to de-risk projects and to make a project more likely to go forward, because the risk that we've taken off of the project by doing validation ahead of time. That's the whole goal for today's presentation, and so you could leave now and take that away if you wanted to. But and sorry, I'll probably get distracted at some point. I'm extremely distractible. This isn't really conducive for someone like me, but yeah, it's all right. So yeah, like I said, Ben Thomas is my name. I've been with Mitsubishi Power going on 12 years now. I started out in the gas turbine side, spent a lot of time in combustion, and then I transferred over to hydrogen about 4 years ago. I've been doing that ever since, and I love it. And I'm a student, most importantly, I'm a student of the energy transition. I love all things energy transition. I like to learn. I've learned a lot here this week. It's been awesome to be here and hear from all the different speakers, presentations, going around to the booths. So thanks to everyone. Okay, so Mitsubishi Heavy Industries and Mitsubishi Power are kind of very uniquely set up for success when it comes to validation. We have a facility that's within our manufacturing facility in Takasago, Japan, where we validate and test everything. So in 2003, we put a unit called T.1 in there, and we ran it for roughly 20 years or 17 years or so, upgraded it over time, and we used that as our first test unit that we then would sell to customers after we had validated it for a year or more. So that's been going for a while. We just replaced that unit in 2020 with a bigger scale one, the JAC class, 1650 degrees C firing temperature. This approach, and this is all talking about power gen, but really it's important for the approach that we've tried to parallel and continue with hydrogen production, and that we created immediately adjacent to that new unit there that's shown there. We put, oh, excuse me, I didn't mean to do that. We put a hydrogen park right next to it, and I'll talk about what's all going in there, but it's basically a place where we can have the full life cycle of hydrogen from production, storage, and then consumption. And we have the ability to use that hydrogen in different ways, like in the JAC class turbine that's there. There's a couple other ways that we are looking to use it. It's a way for us to validate not only our production technology that I'm specifically interested in, but also the end use of hydrogen for combustion, which is kind of critical for our traditional power gen business, right? But first, I want to talk about the ACES Delta project, or Advanced Clean Energy Storage project in Utah. Our marketing team's done an amazing job kind of sharing about this and getting it out there. So probably this is not new to a lot of you, and I apologize for that. I want to go over it a little bit because it kind of highlights the need for collaboration in validation. So this project is exciting because it's kind of everything all in one place, right? So you have, it's built on a salt dome where there's currently 2 salt caverns being solution mined right now, where green hydrogen will be produced in an electrolysis facility right above. You can see the 2 buildings there in the rendering, and then compressed and put into the cavern. Then, and that would be run on green hydrogen, essentially green hydrogen, so it'd be renewable power, curtailed power, anything that's low or zero carbon produced power, renewable energy. Then, when needed, the hydrogen would be pulled out of the salt cavern and run into 2 simple cycle or combined cycle gas turbine power plants that we're also building immediately next door to this facility. So it's all happening right there, and that's going to, on day 1, those are going to fire 30% hydrogen blend, and with a plan to get to 100% by, I think, 2035, 2040 sometime there. We're developing that technology for 100% dry low NOx combustion now in our hydrogen park in Takasago. But in order to do that, it really required a lot of collaboration. And that's the point, is there's a whole list of names there that have all participated in some way in this project. I won't go through all of them. And really, we heard from the CEO of our development side, Michael Ducker, in the other session yesterday, where he talked about like transparency and collaboration being key to the success of this project, right? Everyone came together and I think someone else used the visual of like holding contracts at arm's length, but rather just opening up, and everyone got together and said, how do we need to get this, what do we need to do to get this across the finish line? That resulted in getting a DOE loan guarantee for $503 million, which is critical for the project, and then all the collaboration that's happened since then. One of those collaboration pieces, and this is what it's a long way to get to where I'm going today, was around technology, right? So at the time that we booked all of this, there was the capacity required, 220 megawatts is a lot of electrolyzers. And we were looking at, all right, well, what do we do? How do we not just buy something that is unvalidated at this scale, right, to be produced at this scale? So we did two things. First, we worked with the supplier, Hydrogen Pro in this case, and we built a validation facility of a 5.5 megawatt stack, which is the core building block of the ACES Delta project in Utah. And we put it in there in 2022 and tested short-term testing in the industrial park and validated performance, design, control, all of the things that we knew we were going to have to replicate in the next year and a half for 40. From there, that's short-term though, we didn't have like an offtake locked up there, so we didn't want to run just continuously. And we built in our hydrogen park, we put another one of these units there. That alkaline electrolyzer that's shown in, if you can see 1-1, is that big white building. I spent a couple months there during commissioning last year. That's where another of the alkaline electrolyzers is located, and that's actually making hydrogen that's compressed, stored in the number 2 shown there, tons of bottles, right? I think we got like 39,000 norms of hydrogen that we can store there, and then we use it in our T-point facility, which is with the gas turbine that I told you about. There's also, just off the page to the left, there's a combustion rig facility that's not attached to a turbine. It's where we validate our combustion technology before it even gets to the gas turbine. So we've built this entire environment of validation where we're taking, and in order to have success at the project like the ACES Delta project in Utah, we're spending our money to put technology in our own facility and run it and really beat it up as much as we can to try and break it, essentially, to reduce the risk for the commercialized project, right? Because we've signed up for guarantees, we've signed up for commitments, and we want to make sure the end customer is happy at the end of the day. And this is truly the culture of MHI, is one of validation, it's of transparency, of testing, and showing what we do and how we de-risk customers at the end of the day. And this exciting time, we also used that, so I talked about the JAC, we also used that hydrogen that we made from the alkaline electrolyzer and stored it. We tested in T.2 in the facility there, and we did 30% co-firing. And believe it or not, that amount of hydrogen, 39,000 norms, is like enough for an hour on 30% blend for the JAC turbine. But they need a lot of hydrogen. But we successfully validated that last fall, and we're going to continue to validate that technology. We're looking and doing rig stuff right now. We've also got a small H25 40 megawatt series that we're validating on higher levels of combustion firing. This ecosystem is where we're at. We also just previously announced that we're successful in commissioning of an SOEC electrolyzer 1-2. You can kind of see the shell of it if you look and squint. There, it's a 440 kilowatt SOEC that we're scaling up over time. So pretty exciting stuff. We're adding more to that. So this hydrogen park is going to have multiple production technologies that we're going to be validating from our design, from others, that we are all testing that hydrogen and making the hydrogen to be used in various applications, all there within the park. It's a way to validate together. And so that was our real key goal for the hydrogen park, for validation, and how we were able to test and continue to run the units that are now installed at the Advanced Clean Energy Storage Project in Utah. All 40 are delivered, sitting there on site, about to start into cold commissioning. Like this year, we'll be in commissioning this year. And so pretty exciting. This project is real. It's happening. I've been there recently. Everything's pretty much ready to go. So I think everyone's kind of watching this going, okay, it's like first real purpose-built green hydrogen facility of this scale, this magnitude, 220 megawatts. And I think it's going to be an exciting project to watch in the next year to two. I saved about 4 minutes for questions. So we've got support to help give you a microphone if you want to have a question you want to ask. I didn't tell you that you were going to have questions, so you might not have any. Any questions? Got one. Hey Bob.
Would your company be interested in looking at very novel new approaches of generating hydrogen?
New approaches, like different technologies or
yes.
different.
Yes.
Yeah,
something
we're always.
That I haven't seen.
Yeah, we have a group that looks at technologies and depending on the stage of where they are, if they're laboratory or whatever, we have a group that evaluates all of those, right? So that's the whole purpose is called Next. Yeah.
Can we talk later?
Yeah, I'll give you my card. Bob's got a question, I think.
Hey Ben, 2 quick questions. The dry low NOx, that's like the commercial version that the 30% hydrogen was born in.
That's right.
Correct. Okay, thanks. And are you doing ammonia combustion work?
We are.
Okay.
Yes, we're doing ammonia combustion. Thanks for the the seed question there. Yeah, so ammonia is the other exciting thing that we're working on. It's not in Hydrogen Park. It's in our Nagasaki Carbon Neutral Park. It's a mouthful, but we're developing an ammonia combustion there. We've successfully tested ammonia combustion for like 100% operation on a smaller scale, and we've signed up for some projects. I think that's all publicly announced, so I'm not going to say it here. But yeah, we're doing ammonia too. I think we're kind of leading the industry in that approach. That we've already done some testing. We've got a facility where we can test continuously in Nagasaki, and that is going to continue to go. I think there's some other challenges associated with ammonia that need development too, not just the combustion piece. There's the fuel-bound nitrogen that creates NOx when you have that. So there's some additional technologies that need to be built around that, so you're not, adding NOx, into the environment. But yeah, all that development's happening, and thanks for the ad there.
One quick clarification: is that atmospheric for like furnaces, or is that high pressure for gas turbine fuels, or both?
Both. I don't remember the pressure ratio of our H25 off the top of my head, but yeah, it's the H25 unit that we're doing right now in ammonia.
Thanks.
Yep.
Thanks, Ben.
Any question here, I think? And I got a minute and a half left. So.
Question? How close are you to 100% combustion?
Good question. I don't think I can say publicly. So we have the rig facility that's immediately adjacent to the hydrogen park. I'll show you here. It's just off the screen. We're testing all the time there. There's an H25 that runs the compressor that runs it, and there's all sorts of validation happening. I can't share what we haven't press released yet. But I mean, 100% combustion is something we've known we could do in a diffusion state for a long time, right? Diffusion combustion is like, basically we'll eat whatever you throw at it, but it's going to have high NOx. So this is dry low NOx combustion. To be clear, that we're developing. It's, we know we can do diffusion combustion already at 100% hydrogen. Hope that answers as well as I could. One question left. I probably got time for one more.
Hi, I don't see PEM on there. Are you guys doing PEM as well, or sticking with the alkaline and SOEC? Maybe
so don't have any plans for PEM at Hydrogen Park. And then there's some other technologies that we've talked about. There's the SOEC. I think pyrolysis has been mentioned additionally that is being developed. Yep. That was it, I think. I'm 14 seconds left. So thank you. It's been a pleasure. I'll be around for a little bit, and then I'm going to run out and catch a flight. So Thanks. See you.